KD2DWC, and Kyle is 18 years old, and you're going to love this demo. His topic is the rapid deployment of antennas for portable operation. In portable emergency operations, there is the problem of keeping the wire antennas neatly stowed and rapidly deployable. We always need to be untangling them. The solution, his topic, band in a bucket. This is an HF dipole where the center insulator balun is integrated into the lid of a plastic pail. The legs of the dipole will be wound on a spool. It all gets sealed up in the pail and stored in the truck on a shelf for when it is needed again. And he's from a terrific group of friends in New Jersey that you'll be hearing more about too. And they've got a whole crew of youngsters that they brought with them, and you must stop by that 225 booth to be able to see them in action. They have actually things going on there that they're building that you can see up close and personal. Kyle?
So as Carole said, I am Carole with KD2DWC, and this is the rapid deployment of antennas for portable emergency operations. So I got my technician's license a little over a year ago, and I'm currently working for my general class license. I'm a senior at Warren Hills High School, and I'm the captain of the first robotics team there. In the fall, I will be studying mechanical engineering at the New Jersey Institute of Technology, and they love me in that as well. So with FIRST is a program started by Dean Kamen, and he wanted high school students to be interested in STEM careers, which is the science, technology, engineering, and mathematics. And his goal was for youngsters to get involved in these fields and to go pursue this in college to help make America a technological powerhouse that it was before. And so with FIRST, I've learned a few things. First thing I learned is about teamwork and how to work a team in order to solve real-world problems using what's called the design loop. So the design loop is you start with the problem, and we talk about different solutions to this problem and continue to refine our designs until we have something that works. Turns out it doesn't work, so we redesign it again, and we come up with a prototype and continue to tweak it until we have a solution we're happy with. The third thing that FIRST gave me access to was what's called 3D printing, which is an additive manufacturing process. So it's extruded plastic and it prints in layers, so you can create something new instead of subtracting as you would from a mill or a lathe. And our first team won this in a lottery. They gave away 12 printers to only about one of 5,000 teams. And I was able to take this home with me to play around with it, to learn how we could apply it to our team. I'm also a member of the 721st Mechanized Contesting Battalion, which is a group of young students, both high school and college, and a few old guys. We're based in Northwest New Jersey, and every contest we do, we treat like a field day. So we take our military deuce and a half out to a new location, we take out our mobile radios, we set everything up on site, and we operate. And yes, we are the same guys that had the Bullbot from last year. And since we operate portable a lot, we kept running into this problem where our wires would just be tangled. We would get them out of the trunks of our cars, the bins, and it would just take a long time. It became a real pain to set up every day. And it's a chore to properly store them after you're done with field day or a different contest because you're tired, you want to get back. And if an emergency situation arose where time is of the essence, you want to be ready to go immediately. And so we wanted to create something that was easy and quick to deploy. We wanted it to be simple to take down, self-contained, so only a few removable parts, and we wanted it to be able to hand off to someone, even if they have little to no knowledge of ham radio, and have them be able to set this up so that you could operate quickly. and wanted it to be convenient to store and easy to know what it is. Our original design was the standard ham radio or robot mentality. Make it work with what you have. So our idea was to go on with, we called a Home Depot raid, where we're going to go get PVC pipes, insulators, miscellaneous hardware, and piece something together in the parking lot on site. But it was just becoming too complicated, and it wasn't something you could easily share with other people, which is what we wanted. And there needed to be a better way to do this. And I happen to have this 3D printer at home, so I figured I might as well use it. So we started to get into 3D design in a program called Inventor, which allows to model stuff and we're able to share it with each other without having to get a physical model in hand, which saved a lot of time. And through Google Docs, we shared and tweaked this project to everyone in the 721st before printing. And we came up with what we call Band in a Bucket. So it is a 3D printed piece which we attach to the bottom of a bucket lid. And this one consists of a 20-meter dipole and a valve, along with 50 feet of coax, which we wrap up at the bottom of the bucket. We chose 20 meters, even though 40 and 80 are more common for emergencies, because we needed 20 meters for field death. And back to Inventor, it has what's called parametric modeling, which allows you to tweak a few variables and everything will scale with it. So if you needed the ballon to be longer, you change a few numbers and it'll scale with everything. The threads that we have on the bottom, a few more variables, and you can get it to fit a different application. And this is going to be a short video of it 3D printing. So why use 3D printing? 3D printing is a new way of thinking of how to approach a problem. Normally it is how can we modify what we have to make it work for what our problem is. With 3D printing we can create something new, a brand new solution to our problem. And just a quick information about how long this took. It's about an hour and a half for each of the 3 pieces, and 3D printing allows you to have so many different options of different materials to work with. We chose what's called ABS plastic because it's a strong, more durable material, which is what we needed for this application. Next, I'm going to show you a quick video of how quick and easy this is to set up and start operating. So this design is a multi-purpose design. You're able to suspend it from a tree, as I showed in the video. The bottom of this piece has threads, which are the standard for a broom or a painter's pole, so you can put it in a field if you have nothing tall around you and get up maybe 20 feet in the air. Or if you happen to have a robot that climbs poles, you can put it on that too. My mentors say that while in operation, it's great for holding soda. And I'd like to thank first Carole Perry for giving us the opportunity to present this, the Radio Club of America, and everyone in the 721st for helping me design this.
Okay, while they're congratulating each other, could the three of you just wave to the audience? These are the three adult mentors of the fabulous kids. Thank you all. Okay, I have a special request from a parent, and I can't deny that ever, but I'm going to ask